The latest discovery of the James Webb Telescope could change the universe. 6 strange light phenomena are currently presenting researchers with an unsolvable puzzle. What is the James Webb Space Telescope really showing us here? Researchers initially said that these mysterious light signals were galaxies, but doubts have since arisen about these theories. What do we actually see at the edge of the observable universe? Are these traces of another dimension that prove to us that our world is completely different from what we thought? And do these light phenomena provide the first real proof that our universe is just one of many? Have you ever looked up at the night sky and wondered what you are really seeing? Perhaps you would spontaneously say, of course, stars. But that's only partly true. Yes, you can see the light of many thousands of stars, but you can also see some galaxies, bright planets such as Venus or Jupiter, and of course, our moon. But you also see into the depths of the universe and you see the past. None of these stars are still real today in the places where you see them. They have long since moved on and you only see their light, which was emitted at some point in the past. Light takes a few years or even millions to billions of years to reach us in the vicinity of the Earth. You may see 2 stars in the night sky that seem like neighbors to you, but in fact, one star may be a very close and rather dim star, and another one that appears right next to it may be hundreds of light years away. It only appears similar to its apparent neighbors because this star is perhaps much more luminous and therefore just as much light reaches us from it, even though it is further away. It's a bit like seeing an island archipelago from a ship in the distance. From a distance, some of the islands may appear to be strung together like a chain, and it may even seem as if you could swim from one island to another in a few strokes. As you get closer, however, you realize that there are greater distances between the islands than you thought, and that the distances could hardly be covered by swimming. Be aware of this when you look up at the night sky. Perhaps you will suddenly perceive more spatial dimensions of the universe, and the seemingly 2-dimensional carpet of flickering lights will become a tangible space. Nevertheless, you must not forget that you are still looking into the past. You are looking into an imprint of light and not into reality. Galaxies so old that they blow up the universe? It's a turnaround the likes of which we haven't seen in science for a century. With its ultra-sensitive infrared technology, the James Webb Space Telescope blows up everything we have ever been able to observe in the universe. Webb can detect light that is so fine and thin that our human eyes could never perceive it. Nevertheless, even this marvel of technology can only record light that has traveled through space for a long time, which means that the telescope can only image the past. Imagine the spacious night sky once again. You have thousands of stars, all at different distances. Larger and distant stars can appear closer to our eyes than faint and nearby stars, and we don't know exactly where these light sources are today. Webb works in a similar way to our eyes, only it sees the light trails of stars and galaxies that have traveled billions of light years. In this way, light sources that are very old from our point of view appear in the very background of the image. The first image, published by NASA in the summer of 2022 after Webb's launch, was a deep image of the universe. Here we can once again see the technology and the effects of the light journey very clearly. To achieve this brilliance, the researchers expose an almost empty area of the universe in the foreground. Over a period of hours, the telescope then collects the finest traces of light from the background of this area. If we were to look where this image was taken, we would probably just see a dark night sky with remarkably few or no stars. Due to the absence of the sources of interference in the foreground, the oldest objects in the background become visible. In this case, these are the orange or reddish light sources. The colors are caused by an effect that scientists call redshift. Due to the long journey through time and space, the light is shifted to a reddish color. The redshift actually also occurs because the sources that emitted the light so long ago have also moved spatially away from us due to the expansion of the universe. The rate of redshift is therefore a perfect indication of how far away an object actually is and how long the light has been traveling to us. Scientists use the effect to determine the age of light sources, and in the case of this depth image of Webb, there were some surprises. The first confirmed light source, which is probably a galaxy, was an object with 11Z. That puts us at an age of 13.5 billion years. This means that this light source already existed 300 million years after the Big Bang, and here we have a problem. In this epoch of the universe, there should not have been any light sources of this type and size. In purely mathematical terms, we are at a time when at most the first stars and loose groups of stars were formed. However, Webb analyzed this light and came to the conclusion that, if these were galaxies, they were already very massive, luminous, and astonishingly well-developed, which absolutely argues against these galaxies being among the first in the still young universe. Shortly afterwards, another whole galaxy appeared, which even had a z-value of 13, and thus shone brightly and perfectly formed in space just 200 million years after the Big Bang. These shocking discoveries were followed by others. In the months following the first sensational reports about these impossible galaxies and breakers of the universe, images of 6 galaxy candidates circulated in the media. These possible galaxies are called candidates because it has not yet been possible to confirm 100% that this light was actually emitted by galaxies. And here we come to the exciting point, because if these are not galaxies, what are they? 6 galaxies from a mirror universe? It's a fact that we still don't know how big the universe actually is and whether it has a boundary. We have not yet found a spatial boundary. We look about 46.5 billion light-years in each direction and thus have a view of a space of around 93 billion light-years. But as I said, we are always looking into the past and not into spatial reality. A boundary has not yet come into view, and there are no real indications of one. All theories about this edge or a boundary are ideas or speculations. With our theory of the inflation of the universe and the Big Bang, we thought we had at least found a beginning in time. But on closer inspection, these were also just theories and speculations that made sense mathematically and physically, but the real evidence was missing. Webb should have provided this, at least to the extent that the new telescope could have shown us the first epochs of light generation in space. But instead of the first thin light sources and chaotic star clusters, the telescope presumably shows us perfect and astonishingly old-looking galaxies. Since these discoveries, the scientific community has been buzzing. Some have proclaimed the end of the Big Bang theory. Others claim that galaxies were formed much more quickly than previously assumed, and still others have come up with completely new calculations of the age of the universe. It becomes particularly exciting when these light sources are interpreted as references to theories of quantum physics. There, the multiverse has long been an inescapable truth, and other dimensions, time superpositions, and the variability of realities are virtually proven. So could it be that we are seeing perfect galaxies here because we are not looking at the beginning of our universe, but into a mirror dimension? This idea is really fantastic, and it was given further fuel when researchers announced the existence of Schrödinger's galaxy, or Sears 1749. Measurements of this galaxy showed the incredible fact that it exists in 2 positions and at 2 times simultaneously, which is very reminiscent of exactly this property of quanta. These smallest particles of matter also have the habit of only being fixed in time and space when they are determined by a measurement. It is possible that the Big Bang never really existed, and that instead of a temporal beginning, we find the transition to a parallel world at precisely this threshold. We will need further observations and measurements to confirm this, but we can already look forward to many new circumstances and groundbreaking views of a completely different universe. 6 gigantic quasars at the beginning of time. This telescope is truly amazing. Let's take a look at how the James Webb Space Telescope reads incredible details from light. The light from these 6 mysterious light sources appears tiny, blurry, and meaningless at first glance. But for Webb, light is full of information. Even in quantum physics, light is the carrier and messenger of information in space. At some point, this light was emitted by objects that may have contained several million stars, and even over these vast distances, the information has been preserved. We could never recognize or read it with our own eyes, but Webb can. Ultra-fine spectrometers break down the light signals into their individual frequencies, and in this way the telescope can provide information on the intensity of the light source, the elements present, and other important aspects. This is fantastic, but Webb cannot provide all the details at these enormous distances. For example, it remains unclear whether these objects are really normal galaxies. The immense light could also have been emitted by gigantic black holes. Some active galaxy centers contain black holes and quasars that shine brighter than an entire galaxy. The light is produced by matter accumulated there, which is heated by the power of the black holes and quasars to such an extent that it shines brighter than millions of stars. So is this the solution to the mystery? Are there no galaxies to be seen here but black holes? The explanation could be plausible, and there is still a small problem. Even quasars and black holes of these enormous dimensions should not have existed at the beginning of the universe. Click subscribe.